Hello, we are talking about quadratic equations and quadratic functions. And what you see on your screen here is f of x. I have some function here. F of x is equal to x squared. And I know it's quadratic because I see that x is squared here. So what we're talking about in this video is finding the zero or zeros of a quadratic function. And what that really means is, where does this function intersect the x-axis? So where are my x-intercepts? And for a parabola, there may be one x-intercept, two places where it intersects the x-axis, or sometimes none. So today we're going to look at a little bit of that here, and then in a different video, I'll show you when we would have no zeros for a function. So the real question here, if I'm thinking about it, okay, get my pen so I can draw. If I'm thinking about it, if I'm looking for an ordered pair where this function crosses the x-axis, then I know it's where y has to be 0, right? So what is x when y is 0? So we're going to call these x values the zeros of the function, where I would get y to be 0. So I'm going to put this right here because I want to know, what is x? Fix that a little bit. What is x when y is 0? So now if I factor this out here, x squared is x times x. So what are my options here? What can I put in for x that will give me 0? And I know that the only answer here, okay, is that x is 0. Okay, so that would mean my ordered pair here for this function, the 0 of this function would be that ordered pair where it intersects the x-axis would be 0, 0. Let's look at the graph of this just a little bit here. So now I'm looking at the graph for this pair, and I'm looking at y equals x squared as I've entered it this way, just really quickly. And if you notice, there is 1, 0 for this function. I see my parabola. Let me try that again. I see my parabola, and this is the symmetry that I see here. And there is 1, 0. There's one place where this function intersects the x-axis, and it's right at 0 where we calculated. Try something else for this. So now I have standard form. Got my y equals x squared plus 5x plus 6. Now the question is, what is x so that I can get y to be 0? So where y is 0, what would x be? So the first thing I need to do is factor this out here, right? So I can figure out when y is 0, what is x? Okay, and it's a little harder just to try to figure that out in standard form, which is the perfect time to factor. Perfect time to take this standard form and change it into factored form. And this is why the math teacher makes us do that. I have a positive 6 here. So positive and positive, since this is also positive. And if I think about it, 3 times 2 gives me a product of 6. And 3x plus 2x using my FOIL method would give me a 5x here. So I have factored this. So the question is, what can x be so that I can get y to equal 0? Two options here. One option is 0 is equal to x plus 3. That's one option. And another option, 0, I don't know why that one was bigger, is equal to x plus 2, right? So 0, if the right value is here, to turn this part into 0, then the whole product will be 0, because 0 times whatever this is will give me 0. Or if I have the proper number here to make this overall value be 0, then it doesn't matter what's here. 0 times that number will yield 0. So without having to do a complete equation, we know that right here, okay, this x value would equal, and you're saying it, -3, right? Because -3 plus 3 would give me a value of 0. Here, you're saying it already, x has to be -2, because -2 plus 2 would give me the 0. And now if I turn that into ordered pairs, then I could say this function has 2 zeros. There's 2 different ordered pairs here where I would get y to be 0, right? If x is -3, then y will be 0. If x is -2, then y will be 0. Okay, and if I look back up at my original, I could check it. I could literally sub in -3 and do the calculation, and y will be 0. Or I can sub in -2, do the calculation, and y will be 0. Let's check this on our graphing calculator. So let me adjust this a little bit. Back at our trusty Desmos. I'm going to make that one go away and make this one come up, okay, and adjust here. So check it out. I have this parabola for the function x squared plus 5x plus 6. That's just what we took and made into factored form. And we said the 2 zeros, right, we just said it, would be at -3, and you can see it in the corner there, -2. And if you look here, look at the 2 points where this intersects the x-axis. Intersects at -2, 0 and -3, 0. Voila. Let's do one more. Okay. Need to get one more screen here. If I can get it. All right, this is the final screen that I wanted. Had a technical difficulty there. So y equals x squared minus 2x minus 3. And the teacher is asking you to find the zeros for this quadratic function. So what that means is I've got to find the values for x that would yield an output of 0, because wherever that is, that's going to be the x-intercepts for that graph. Now, if I just have to start trying to figure out what numbers go here and here, then we get to more complicated functions. That becomes a very tedious task. But if I know how to factor, then life is easier. So x here and x here, since that a value in front of x squared is 1. And I notice I have a negative sign here. So one of these values is going to be positive, and one of these is going to be negative to yield a -3. And I'm thinking 3 times 1, prime number right there. So I'm thinking if I put the 3 here and the 1 here, I get 1x minus 3x, that yields -2x, and then of course my -3. Okay, so I've properly factored this. Now that means there are 2 values for x that would yield 0 when I look at this. So I already know without graphing that when I look at this parabola, there are going to be 2 places where it intersects the x-axis. Those are my 2 zeros. So this one, 0, that's a fancy 0, x plus 1, and then 0 equals x minus 3. So in this case, if I think about it, that x value has to be -1, right? Because -1 plus 1 would give me 0. And this x value has to be 3, because 3 minus 3 would give me 0. Now, when we get into more complicated expressions here, you would want to make sure you know how to solve this equation, like subtract 1 from both sides, x equals -1, add 3 to both sides, and you get x equals +3. So I have that x is -1 and x is 3. So without writing this here, you would know that ordered pair is -1, 0, and this ordered pair is 3, 0. So let's check with our graphing calculator. So let's check this out here. Let me zoom out to see what we're looking at. And if you notice right here, I have x squared minus 2x minus 3. And take a look at this parabola here. It intersects at +3 and -1. So let's double check. We said +3 and -1. And there we go. +3 and -1. Now, on a test, they might ask you, what is the +0 for that function? The +0 would be +3. What is the -0 for that function? The -0 would be this -1 right here, okay? Or they might ask you, which is the greater 0 value? Obviously, that's 3. Which is the smaller of the two 0 values? Obviously, that's -1. So when you get to this point, then you just have to go back and be very careful about what they are asking you to provide as far as the information that they want you to give to them. So to review, this is how we find the zeros of a function. We factor, right? We factor the function and then set each possibility equal to 0. This could be equal to 0 if -1 is here, and this would be equal to 0 if +3 is here, and I only need one of them to be 0, right, to give me an overall product of 0. And so this function has two zeros. That first one we looked at, let's go back to here, that only had 1 0, and some quadratic functions will have no zeros, and we'll look at that in a different video. Thank you.